Motorsport has always been about pushing boundaries. Speed, innovation, and testing the limits of engineering and physics are the cornerstones of the sport. Over the decades, we've seen cars that changed the game, redefined what was possible, and etched their names in history. But one story stands out for the way it shattered conventions and how it still remains a symbol of unrealized potential. That's the story of the DeltaWing project, an experiment in car design that could have revolutionized motorsport, but ultimately became a legend of what might have been. In 2009, the motorsport world was at a crossroads. IndyCar, one of the top racing series globally, was hunting for a new car design to debut in its 2012 season. The stakes were high. The sport needed a fresh, innovative design that could keep up with the demands of modern racing. Something faster, lighter, more efficient. Leading manufacturers like Dallara, Lola, and Swift prepared their submissions, each with a proven track record and evolutionary design approach. These companies had been refining race cars for years, making incremental changes to established ideas, always improving on what worked. But then came the DeltaWing. It was unlike anything anyone had ever seen. When designer Ben Balby unveiled it, jaws dropped. It wasn't just an evolution, it was a revolution. The DeltaWing didn't just challenge the existing rules. It looked like a car from a different planet, something that had never been tried before. It was a bold vision, a car that could match the speed of an Indy car, but do it with half the power, half the weight, half the drag, and half the fuel. These were huge claims, and most of the racing community thought that they were too good to be true. But Balby wasn't just dreaming. He had a well-thought-out plan based on solid engineering principles that turned the very concept of a race car design on its head. At the heart of the DeltaWing project was a complete rethinking of aerodynamics and physics. Traditional race cars were designed with wide, heavy front ends and relied on large wings to generate downforce. These designs allowed the cars to stick to the track, but they also created massive drag, which required powerful engines to overcome. Most of the power generated by these engines was used just to counteract the drag force, leading to inefficiencies. The DeltaWing, however, approached things differently. Instead of maximizing downforce, Balby sought to minimize drag. One of the most striking aspects of the DeltaWing was its incredibly narrow front end. The front wheels were placed much closer together than on a conventional race car. The car's frontal area was so small that it dramatically reduced its drag coefficient to 0.24, nearly half that of a typical Indy car. To put this into perspective, the average drag coefficient for an Indy car ranges from 0.5 to 0.8, depending on the aero package used. Lower drag means the car needs less power to maintain high speeds. With the DeltaWing, this enabled the car to achieve performance parity with traditional race cars using just a 1.6-liter turbocharged engine, which produced around 300 horsepower. For comparison, an IndyCar engine at the time produced around 650 horsepower from a 2.2-liter V6 twin-turbo engine. What's even more impressive was that the DeltaWing, with its modest power output, could still reach speeds of up to 200 miles per hour. That's not far off the performance of traditional Indy cars, which regularly hits 230 miles per hour on ovals like the Indianapolis Motor Speedway. But the key difference was in how the DeltaWing achieved those speeds. Because it was so lightweight, less than 500 kilograms or 1,100 pounds, and had such low drag, it used far less energy to get there. One of the most radical aspects of DeltaWing wasn't just its narrow front, it was how it distributed weight. Most race cars aim for nearly even weight distribution between the front and rear axles to maximize stability and handling. However, the DeltaWing had 76% of its weight over the rear axle, which was a stark departure from the norm. In a conventional car, this would be considered risky, as it could lead to understeer. But Balby designed the car with rear-wheel drive and his extreme weight bias to enhance traction at the rear wheels, where the power was delivered. This design wasn't just about weight balance, it was about efficiency. The heavy rear end meant that the car had much better grip when accelerating out of corners, which allowed it to maintain higher speeds through turns while requiring less engine power. Additionally, the DeltaWing's lightweight chassis, made from advanced composites, helped it to achieve an overall curb weight of 500 kgs, significantly lighter than its competitors, which weighed around 700 kg or more. The front suspension was another engineering marvel. Instead of relying on bulky, traditional suspension setups, the DeltaWing borrowed technology from mountain bikes, using lightweight materials to keep the front end as nimble as possible. The front wheels, which were a fraction of the size of the rear wheels, further reduced the car's rolling resistance. In total, the car was about 40% lighter than a conventional race car, giving it significant advantage in terms of fuel consumption and tire wear. Despite its groundbreaking design, the DeltaWing's path to the racetrack was fraught with challenges. When the time came for IndyCar to select its new base car for the 2012 season, the series opted for the safer, more conventional Dallara design. It was a disappointing but not entirely surprising decision. The DeltaWing was too radical, too unproven for a series that was deeply rooted in tradition and continuity. After being passed over by IndyCar, the DeltaWing's creators knew they needed to find a new home for the car. That's when they set their their sights on endurance racing, and specifically the 24 Hours of Le Mans. Le Mans has always been a proving ground for cutting-edge technology, from turbocharged engines to hybrid powertrains, and the DeltaWing was no exception. In 2012, Le Mans introduced the Garage 56 category, which allowed experimental vehicles to race outside the traditional rule set. It was the perfect opportunity for the DeltaWing to prove itself. The DeltaWing's inclusion in Garage 56 was both a blessing and a curse. On the one hand, it gave the car a platform to race, something that had seemed unlikely after IndyCar's decision. But on the other hand, the car wouldn't be eligible for an official classification or a podium finish. It would be racing against itself, serving more as a demonstration of what was possible than a competitor vying for victory. Nevertheless, DeltaWing's presence at the Le Mans generated huge interest. Fans and engineers alike were eager to see if this radical design could live up to its lofty promises. The car's distinctive look, with its narrow front end and wide rear, made it stand out on the grid. Even among the high-tech LMP1 and LMP2 cars, the DeltaWing looked like something from the future. When the DeltaWing finally hit the track at Le Mans, it didn't disappoint. At least not at first. Despite having just 300 horsepower, the car was able to reach competitive speeds, especially in the long straights of the Circuit del Sarte. The DeltaWing's low weight and superior aerodynamics allowed it to keep pace with cars in the LMP2 class, which had much more powerful engines. One of the DeltaWing's most impressive stats was its fuel efficiency. Throughout the race, the car consistently outperformed its competitors in terms of fuel consumption, making fewer pit stops and staying on the track longer. The team behind the DeltaWing had designed the car not just to be fast, but to be efficient. And in this regard, it was a resounding success. DeltaWing managed 11 laps on just 40 liters of fuel, compared to the 8 to 9 laps most competitors were getting on the same amount. This translated into a fuel consumption rate of around 27 liters per 100 kilometers, a remarkable feat for a race car running at full throttle for 24 hours. However, the car wasn't without its challenges. One of the more innovative features of the DeltaWing was its torque vectoring system, designed to improve handling and stability. This system allowed the car to adjust the power going to each wheel individually, helping to maintain grip and prevent understeer. Unfortunately, during the race, the system didn't work as intended. The car struggled with wheel spin, particularly on the inside wheels when accelerating out of corners. This issue limited the DeltaWing's ability to fully utilize its power, especially in the more technical sections of the track. And then disaster struck. After completing 75 laps, the DeltaWing was involved in a collision with Kazuki Nakajima's Toyota LMP1 car. The impact severely damaged the car's suspension, and despite the team's best efforts, the DeltaWing wasn't able to continue. For the team, it was a crushing blow. The car had shown so much potential, and many believed it could have gone on to achieve great things if not for the accident. Despite the setback at Le Mans, the DeltaWing project wasn't over. Later that year, the car entered the Petit Le Mans, a 10-hour endurance race held at Road Atlanta. This time, the DeltaWing finished the race, placing an impressive 5th overall. It was a huge achievement, proving that the car could be competitive against more traditional designs. In the 2012 race, the DeltaWing completed 394 laps, only 24 behind the winning car, a Nissan-powered P2 car. This performance at Petit Le Mans showed that the DeltaWing wasn't just a novelty, it had the potential to compete at the highest levels of motorsport, even if it wasn't yet fully developed. But as 2013 approached, the DeltaWing faced new challenges, both on and off the track. One of the biggest challenges facing DeltaWing was internal conflict within the team. Don Penaz, a key supporter of the DeltaWing from the beginning, had a falling out with Nissan, the car's primary sponsor. Penaz believed that the DeltaWing could be even better if it were developed in-house, without the constraints of a corporate sponsor. He decided to replace the Nissan engine with a Mazda unit and continue to push the car's development independently. Meanwhile, Nissan wasn't ready to give up on the DeltaWing. The company hired Ben Bowlby, the car's original designer, to work on a new version of the DeltaWing that incorporated hybrid technology. This led to a legal battle between Penaz and Nissan over the intellectual property rights to the DeltaWing's design, further complicating the project's future. As these disputes dragged on, the motorsport industry's inherent conservatism worked against the DeltaWing. Many teams and manufacturers were hesitant to embrace such a radical departure from traditional car design, and without a clear development path, the project began to lose momentum. By 2016, both versions of the DeltaWing had been shelved, and the car faded from the racing scene. Although the DeltaWing never fully realized its potential, its impact on the world of motorsport is undeniable. The car challenged engineers, designers, and fans to rethink what a race car could be. It showed there was room for radical innovation in a sport that often favors traditional over experimentation. One of the most important lessons from the DeltaWing project was its focus on efficiency. The car's ability to achieve competitive speed with a smaller engine, less fuel, and less drag highlighted the importance of sustainability in motorsport. In an era where racing series are increasingly looking to reduce their environmental impacts, the DeltaWing's philosophy of doing more with less feels more relevant than ever. The DeltaWing's influence can also be seen in other areas of motorsport. Several manufacturers have since experimented with radical aerodynamic designs and weight-saving technologies inspired by Bumblebee's work. The project also sparked conversations about the future of racing, particularly as the industry grapples with issues like fuel consumption, emissions, and sustainability. In the end, the DeltaWing may not have revolutionized motorsport in the way its creators had hoped, but it left a lasting impression. It proved that bold ideas and ambitious designs can challenge the status quo, even if they don't always succeed in the traditional sense. What do you think? Was the DeltaWing ahead of its time, or was it destined to fail? Let us know, and stay tuned for more motorsport stories.